Hello guys, welcome to this lecture. And in the previous lecture, I think we have just seen about the basics of actually pointers. And one main point that I have told you is that whenever something is created in heap, to access those data or memory block, we need a pointer in stack. We need an address variable in stack. This is what the main point I have conveyed. So now we need to know what is the necessity of creating a memory block in heap. Still now we have doing all the creation work in the stack only, am I right? Still now we are doing all the process in stack, but suddenly why we require this heap? Because I told you that RAM is actually a small memory. For example, if you see RAM is, for example, of my laptop is like 8 GB, and the hard disk of my system is like, for example, 1 TB. Hard disk is 1 TB. Okay, so you can here itself, in this itself, you can see that the RAM is of very less memory, 8 GB only. But if you see your hard disk, it is 1 TB. So this stack is a very limited memory, and hard disk is a vast memory. So whenever you want to use vast memory, then you have to go for heap, not for RAM. So for that purpose only we are going for heap. That's a one main thing that I need to convey. Now you can ask me one more question. So far whatever we have declared is declared in stack only. It is created in stack. Now how to push those things which is created in stack to heap, that we will see now. See, so far we have seen two major collection of data storing data types. One is structure, the other one is array. First of all, what I will show you is that I will show what is the procedure. I'll show what is the procedure to move arrays to heap from stack. First of all, I'll show you what is the way of moving an array from stack to heap. So far what is happening is the array is being created in stack and we are using it. Now I'm going to show you how to create a array in the heap, not in stack. First of all, what I will show you is, for example, I'll just show you first of all int a of 5, which is a array. Whenever you declare like this, what will happen is declare, and let me initialize values 1, 4, 7, 9 and 4. Whenever you declare and initialize an array like this, what will happen actually, I can just show you in this line by line execution. The memory will be allocated in the stack. That I'll show you here. Okay. Okay, see here, activation area is created for mine. Activation area is created in which place? Inside stack. You can see here called stack. And inside this activation area only, this variable section is here. So this inside this activation area, a block is created, which means that inside stack only the block is created, and all the 5 memory blocks are created inside the stack. Okay, fine. And if you execute this statement, what is happening? In the stack only all the changes are taking place. Now what I will show you is that now this memory block has to be shifted to heap. How to do that? How to do that is using dynamic memory allocation. Okay, so in dynamic memory allocation, we are having two ways of doing it. Two functions are there. The first function is malloc. The second function is calloc, the main functions. And the third function we have is free. And this malloc and calloc are for allocating memory, and free is for deallocating the memory. And we have also one more function called realloc. And this free, realloc and calloc, these three things we will see in the separate dynamic memory allocation part, where we will be seeing completely about pointers. Now I will show only one method called malloc, and using malloc we will see how the memory is allocated in heap. First of all, what I will do is I will just declare a pointer like *a. This is a pointer. How to allocate pointer is that you can do two things. One, separately you can allocate, or otherwise in the same declaration part also you can allocate. I'll show you how to allocate in the declaration part itself. Suppose you want an array of size 5. You want an array of size 5. Then what you need to first of all do is you have malloc statement. You have a function called malloc. You have to call this a function called malloc. Malloc means memory allocation. That is what malloc. Okay, followed by a parenthesis. Inside this parenthesis you have to mention an integer. This integer will tell you how many byte have to be allocated. How many byte have to be allocated. For example, if a single integer element takes 2 byte, then if you want 5 integer to be stored, how many byte you require? 10 bytes have to be allocated. So that integer has to be specified inside this malloc. But we do not know the compiler what it is going to take, either 2 byte or 4 byte. It is up to the compiler. So we have an operator called size of, and this size of operator will take the data type, for example int or float or double or any data type you want to find the size for. So this entire size of int will give you the size of the respective data type. So now this is going to give me the size of integer. And if the size of the integer is, for example, 4 byte or 2 byte, then I need to multiply it by the number of elements required, for example 5, because if a single block, okay, for example, if this single block requires 2 byte, and if you want 5 such block, how many byte required? 5 into 2. So what is this? To size of integer. So what I have to give? Size of integer multiplied by the number of element that I require. So now what will happen is that this entire malloc function will return me a null pointer. It will return me a null pointer. We will see what is null pointer. Null pointer means, we will see a null pointer later. Now this is not the time to see null pointer. But null, what does mean by null? Null means nothing. Null means nothing. So it will return me a null pointer. That pointer cannot be used for any purpose. So what I need to do is I need to typecast it. What is typecasting? Typecasting means, I'll just tell you what is typecasting. Casting means, changing the type of data from one format to another, from one to another. So suppose if you are having integer and if you want to convert integer to a float, it is called as typecasting. If we have an integer and we want to convert it into a float data type, then it is called as typecasting. If we have a character and if you want to convert it into an integer, then it is called as a typecasting. So similarly, I get a null pointer, void pointer, and if that null pointer has to be converted to an integer pointer, because I told you that the memory has to be allocated for integer pointer, not for any null pointer. But this malloc will return a null pointer. If that pointer has to be typecasted, then you have to give a parenthesis in front, and that parenthesis must have the pointer which you need to convert to. So what pointer I need to convert to? I need to convert it to an integer pointer. So I'm giving integer star, int star on the front side. So how generally I can tell you is that no need of no confusing yourself with the null pointer. Now just simply I will just tell you, this is the pointer for what you are allocating memory for. You are allocating memory for an integer pointer. So this is for which pointer you are allocating memory for, then followed by the malloc function, and in the parenthesis you need to specify the number of bytes need to be allocated. Okay, now what I will do is I'll just execute. I'll just do the line by line execution, and I'll show you what is happening here. If you see here, activation area for main is created here, and inside the activation area you have a pointer, and if you see here, hexadecimal address, it is referring to hexadecimal address. If I expand it, no 5 blocks, because I have allocated 5 blocks, right? But no 5 blocks is shown here. Why? What is the reason? Because inside stack, what will happen? Inside stack, as I show you here, inside stack only one block is allocated, and this block is having only the address, but the main block is allocated here in the heap while using a malloc statement. So that is what the usage of malloc statement. What malloc is doing, malloc is not allocating the memory in stack, it is allocating the memory in the heap. So that heap address only this A is referring to now, 0x4. This is the address of the memory block which is they allocated in the heap. So now my stack is not having the memory block, my heap is having the memory block, and the initial address, the first block address, is stored in this pointer which is created in the stack. This is that pointer. This pointer is having only the address. Okay, now I will execute this line. Can you able to see? Yes, address is allocated, and what is this? This is a garbage value which is stored by the first block of the heap memory. This is not assigned with any memory, any element, right? So since this is not allocated with any value, this is holding a garbage value. That garbage value is shown here. Okay, so now what I will show you is that how you can access that heap memory. How you can access hereafter, no issues, you can directly access it like a array. How you will access an array? A of 0, A of 1, A of 2. Similarly, like like you access the array, right? Similar way you access. The later part of the pointer section, I will teach you about pointer arithmetic. All those things about pointers will be separately dealt. Okay, so no issues. But I'm just telling you how to allocate memory for a array. Allocate memory for a pointer. So this is like an array. Now what I have done, I have moved my array to heap. So now what I will do is, here I will just do A of 0. A of 0 is equal to 2. A of 1 is equal to 6. A of 2 is assigned with 9. A of 3 is assigned with 23. And A of 4 is assigned with, for example, 3. And now at last what I will do is I'll print all these elements one by one. Okay, so percentage D, 5 elements, right? So 5 percentage D I will just give, and followed by A of 0. You can do loop, you can write a loop to do it, but just for demo purpose only I'm doing this. A of 2, then followed by A of 3, then followed by A of 4, and followed by A of 5. No 5 is here, only A of 4, up to A of 4. Now we will execute the same thing line by line, and I'll show you what is going to happen. See, one thing that we missed is this malloc function. So I'll just stop the process. This malloc function is there in the library called stdlib that we missed. Okay, it is not inside stdio.h. This inbuilt like printf. Okay, like printf, like how printf is stored in stdio.h, this malloc function is inside stdlib. So you need to include that stdlib.h header file, and then only you can use this malloc function. Can you able to see this here? I was watching it here in the here in the bottom section. Actually it was showing that stdio.h was missing. Okay, so I can just show you here. I'll just take it off, I'll just save it. For example, if I just execute, I'll just show you that part also. For example, if I just execute, can you able to see here? Include stdio.h or provide a declaration for malloc. Okay, so stdio.h is what holding it. So I'll just introduce stdio.h. Now if I just compile it, no error will become. Yes, so now I will go for the line by line execution. Yes, fine. So now let me execute this 8th line. This 8th line is executed. Memory is allocated in the heap, not in the stack. And now what is the first line? 9th line, A of 0 equal to 2. You are able to see the heap inside heap memory. In 0th index, what happened? Element called 2 was stored. That is why it is showing. So directly I will be able to access only that base address only, because only base address is stored here in the stack pointer. Okay, so next A of 1, those reflection will not be shown here because those are happening in the heap, not here in the RAM. Here only the RAM part are shown. So heap memory, those things that we cannot able to see what changes are happening there. So up to 13th line I'm executing, then coming to 4th line, 14th line, if I execute, it is completely executed. Okay, if I just go to the debug console, you can able to see here it is printed. In the debugging process, it is printed. What is printed? 269.23.3 is printed here. Okay, 269.23.3 is printed. Right. So I think now it is clearly evident that that pointer is required to access the data which is present here, there in the heap memory. There in the heap memory. Okay, so I think this session is now actually is for 15 minutes. Okay, we can go further also. So next thing that I need to show you is, I have shown you how to take the array and send it to heap. Now I will show you how to take structure and how to send it to heap. Okay, so now what we will see is, we will see how to send a structure to heap. Okay, so first of all, I'll take a very basic structure yesterday we saw, which is rectangle. And this rectangle is now going to have, for example, two members called length, and another one member is called as breadth, or called as breadth. Okay, so now what will happen is, if I want to see this array like this is converted to a pointer like this. Similarly, what has to happen is, if you want a structure, struct variable like this is called as a data variable, struct data variable. But if you want to convert it to a pointer, what you can do, you can add a star in front. If you want to convert it to a pointer, you can convert it into a star like this. What will happen whenever you declare like this? What will happen when you declare like this? I'll just show you here. Only one block will be allocated for every pointer. A block like this will be allocated for every pointer. And this is what will happen in this case also. So what you have declared here is, you have declared a struct rectangle pointer variable called R. So your block like this will be created, and this is called as R. And you can ask me, suppose if simply R is declared, what will happen? If simply R is declared, not one block, two block will be created, and this first block will refer to length, and the other block will be referred to breadth. But now what happens? Now, since I am declaring a pointer, what is happening? Only one block is created. So now I need to allocate the memory. There in the heap. Then only this structure, this two block structure will be allocated. Okay, so how to do that? Using malloc only we will be doing it. Okay, how to do? So let me convert it into a pointer. And how to allocate memory for this? First of all, equal to malloc. And what is the size of structure? You can use that same size of operator. And what is the data type here? The user defined data type is struct rectangle is called as a data type. I told you yesterday itself. Similar to integer, struct is also a, in the morning session only I told you, like integer, struct rectangles is also a data type. So size of struct rectangle will give you the sum of the memory of the members of the structure. So then what you have to do? Nothing else. Okay, so what will be the size of rectangle? 4 plus 4. If it is taking 4 byte, 4 plus 4, 8 will be. So automatically 8 byte will be allocated. What it will be returning you? Null pointer. How to typecast it? In the front side you have to give for which pointer you are allocating the memory for. Which pointer? Struct rectangle pointer. Okay, so I have to give, instead of int star, I will be giving here int rectangle star. So for what pointer you are allocating the memory for? For struct rectangle star pointer you are allocating the memory for, followed by the function. Then inside that you are using size of operator to find the memory for struct rectangle. So now what will happen after executing this statement in your heap memory? Okay, sorry, after executing that statement, a memory like this, a block like this will be created in the heap, not in the stack. That you should be very careful of. A block like this will be created in the heap memory, and now this will be having two members called as length, having the two members called as length, and this will be having a something called as breadth. And this both this block will be having a address, common address. For example, let that address be 0x1234. The address of this both these blocks are 0x1234. And now what will happen, this malloc, this entire malloc statement will be returning the address of the memory block created. It will be returning the base address of the memory block created in the heap. What is the base address? 0x1234. So that 0x1234 will be stored now in this memory block 0x1234. This is what will happen in the previous case also. We did int star a equal to int star. For integer pointer we allocated memory, right? What happens, a memory is allocated in the heap and the base address of this memory block is returned and stored in the pointer variable. Okay, so now if I need to access something here in the heap memory, what I need to do, I told you using dot operator you can access. Using dot operator you can access. How can you access using dot operator? Can you access like this? I'll just tell you. Can you access like this? R dot length is equal to, for example, 10, and R dot breadth is equal to 20. Will I be able to do this? No. You can see the error here also, here itself. Why can't you do like this? The reason why we cannot do like this is, can you able to see here, this is R block, right? This is R block. Is R block is having anything called as length and breadth? Is R is having anything called as length and breadth? No. This memory block which is allocated in heap, this is what having length and breadth. This R block does not have any length and breadth. So completely this is wrong. This is wrong. So how I have to do it? What is the way? So I need to dereference it. So using the address, I need to reach here. After reaching here only I can get length and breadth. So how to reach here? That is what star is used for, to dereference. I have already told you dereferencing. Okay, so use stars in front of it. Will this work now? No, this also will not work, because dot is given highest precedence comparing star. So first of all star will be executed, then only first of all dot will execute. Dot is having higher precedence, so first dot will be used, then only star will be executed, which is wrong. So what we can do, actually we can give a parenthesis bracket like this. So once we give a bracket like this, what will happen, whatever is inside the bracket will be executed. So the star R will be executed. So once you execute star R, what will happen, you will reach here. Once you reach to this block, now this block is having length and breadth, then you can go with dot length dot breadth. So this is the way of doing it. So shall we check whether this is working or not? Yes. So now what I will do is, I will just print a %d comma. Can I do R dot length? No, I told you that it can be done like this. So star R dot length is the way of accessing it. So now the same like star B dot breadth. Okay, not star B, it is star R. So star R dot breadth. Okay, we will just compile it and check and whether this is working or not, and then we will go for with the line by line execution also. Okay, we will just execute it. Yes, it is printing perfectly, so it is storing perfectly. So now I'll just tell you one more way of doing it, but before that we will just look at this line by line execution, and then I will tell you one more way of accessing this member. Okay, so now I'll just execute 10th line. Automatically, if you see here, address is allocated. See how address is allocated. This malloc is allocating the memory in heap, and the base address is returned to the stack variable called as R, and it's stored here. Okay, so now I'll just execute the next line, and if you see inside, it is having length and breadth, and length is changed to 10, and now the next one is breadth is changed to 20. So R, it is a part of your heap, and only address you are having, and the length and breadth part is changed to 10 and 20. And now if you execute this printf part, what will happen? star r dot length star dot breadth. What is length is having 10, what is breadth having 20. Yes, both these things will be printed. And now I'll just tell you one more way of accessing it. Instead of writing star or dot length, you have a direct operator. You have a direct operator, which is you no need of giving star, you can give r arrow mark. This arrow mark will directly tell you that it will directly take you to the heap memory. So when you give arrow mark, directly you go here, you reach here, and then you access length and breadth. So arrow mark will take you to the heap memory. Okay, so now I'll just remove this r star, and instead of dot I will just introduce you to this arrow mark operator. Okay, so here also, instead of star or dot, instead of doing such a little bit, you take time to give the bracket, use dot and everything, you can directly go with this arrow. Arrow means hyphen and greater than symbol, hyphen and greater than symbol. Then coming with r hyphen breadth, we will check whether this is executed properly or not. Yes, shall we see it? Yes, yes, this is also working. So now what we have done is we have moved both our array as well as our structure to heap. Now we know how to declare a memory in the heap. So now we know how to declare array in the stack, also how to declare array in heap also. Similarly, we know how to declare a structure in stack also, we know how to declare a structure in heap also. Okay, fine. So this is it for this session. So I wanted to teach you only the basics of array, basics of structure, and basics of pointer. Okay, so hope I have done it. And if there is any doubt in the only the basics I'm asking, don't ask me for nested structure or double pointer. Those things we will see in the exclusive session that we have for pointers, structures, and arrays separately. Okay, so now if you have any doubts with the basics that I have taught, okay, if you have any doubts with the basic that I have taught you so far, then you can post your doubts, I can clarify it. Okay, fine. In the next session we will be starting with functions. Okay, thank you.